Hey guys, welcome back from the holidays. I've been wanting to do a video for a little while. I've just been really busy and kind of burned out, to be honest with you. But one of the projects I've been working on is a baud rate converter for the RC2014 Z80 computer. I don't know if I mentioned it or not, but I picked up, actually a friend of mine, picked up an old terminal, a VT100 terminal at an event, and that has limited baud rates. In fact, if you look at the RC2014, you'll see that its baud rate is actually 15.2 K baud. And these old serial devices don't support that. In fact, 9600 baud is, I think, the fastest this one will do. And I'll show it to you. We'll actually mess around with it. Long story short, I designed a baud rate converter for it that interfaces with the transmit and receive lines that are already on the RC2014 bus. So that's what I'm showing you right here. So let's kind of get into it, and then we'll hook it up to the terminal and we'll play around. All right, guys, let's see what we got here. So I actually had this board already built, the PCB at least. So here we have the bus, and the key points here are basically voltage and ground. We've also got the transmit and receive lines on the bus. And the trick with doing anything that involves RS-232 communications, which is what this serial device needs to talk to the serial terminal, is the voltage conversions. And fortunately, a long time ago, a chip was created that allows you to do that, the MAX 232 chip. So that's what this is right here, the MAX 232. It does need a number of capacitors, and it uses those to help do the voltage conversions. And also, you really need to be careful if you're not using any of the outputs to pull them to ground. I did have some ringing, I believe, that was going on in the circuit, some oscillations, and they'll heat up very fast. It causes a significant problem. Make sure you read the data specs. So anyway, what is going on here? Let me just back up for a second. What is going on here is that we plug in this down here. This is the DB9 is what I call it, connector. I've heard it called a couple different things. And we get our receive and transmit, and that would be from whatever device we're talking to. And that actually goes through the MAX 232. Then it needs to go through a level shifter, because I'm using an ESP32 microprocessor to do the baud rate conversions. The baud rate conversions aren't being done analog. They're being done through a microprocessor, through software. And that way you can actually change the baud rate. If you need something slower or something faster, you can just modify the software, at least at this point. Maybe jumpers in the future, I don't know. So I'm using this level shifter so that I can get the proper voltages to the ESP32. Those are 3 volts. The MAX 232 wants 5 volts TTL signals, and there's even higher voltages and negative voltages on the RS-232 line. So these chips, this one and this one, are all about adjusting the voltages so the devices can understand it. When we go down to the ESP232, we have a reset line. We've got some stuff in here that's going to allow us to actually program the device once it's on the PCB, so we can still program it. We've got some stuff here, the ESP transmit and receive lines. We've got some test points. And we got some LEDs to kind of help us see that it's actually working, that there's data going back and forth. And I also added support, let's see here, for transmit and receive B, the B lines, which are on the extended RC2014 bus. I'm not using them yet, but what I really want to do with this project in like a phase 2, if I ever get to it, is allow the ESP32 to be a conduit to the internet. So you would install CPM, on your Z80 machine will look, hopefully we'd get some terminal software, and transmit and receive A would be keyboarding input, but B would be an interface to this device that would allow us to get on the internet through terminal software. I don't know if that's going to happen or not, but this design was created with at least that in mind. So I think that's pretty much it. Let's go over to the bench. We'll take a look at the PCB. And from there, we'll actually hook it up to the serial device and look at some old school stuff. All right, guys, let's go to the bench. All right, so one of the things I want to show you is that this doesn't come natural. I mean, I've gone through and built other boards here trying to make this work. Here's a really wired up board. Trying to make the baud rate converter do what I wanted it to. I even went through a couple PCBs being manufactured that weren't correct, or I made mistakes on. So, making mistakes is all part of learning. That's the way it goes. So the final unit, which is right here, like I told you when we were looking at the schematics, it's designed to also be able to support the transmit and receive B lines instead of just the A lines, but we're going to focus just on the A lines for now. I haven't really tested B lines with CPM, etc., but this is a baud rate converter so that you can hook through a serial interface different devices. You can also, by the way, still hook into the FTDI if you want for a serial interface for both, well, I said it's for serial or for programming. One thing to note about my version of the RC2014, and by that I just mean I changed one thing, and that is I'm using a switching 7805. This is generates much less heat. I had used them on some other projects for some old Atari 2600s, and I decided to pull one and add it here. I also am using, external power for mine, so I don't have any power issues. Okay, so with that, let's go over to the serial computer. I'll show you how we actually hook this up. We'll boot it, and we can see what computers used to look like in the 70s, 60s, and 70s with serial terminals on them, even in some cases into the 80s. All right. Okay, so let's take a look at the WISE terminal that I have. And on the back of it, you'll see here where it has two serial ports. I'm using serial 1. Now the key to using this is to use a serial cable, not a null modem cable. A null modem cable actually switches transmit and receive. That's not what we actually want to do. We want to maintain transmit and receive. That's what the card's expecting. So what you do is you plug in your serial, and I will go ahead and do this and spin it around for you. So this is the WISE VT100 terminal. And if we go into the setup, let's see, shift setup, you can see, maybe, you can see that if we look under communications F4, we'll see that I've got it set for 9600 baud. And if we look at that, in terms of changing it, I think, let's see here. Looks like it'll go up to 38.4. And as we know, the RC2014 is running 115.2K baud. So I'm going to put it back on 9600 baud, and we will save. We'll hit F12, F12 again. Okay, so now I'm going to reset. I've got the card in. I've got the serial connection hooked up, and I'm going to hit reset on my CPM, my RC2014, And there we go. We hit spacebar to activate the console. I'm going to reset the card, and you'll see that it actually kind of goes through a little test, and then it says the ESP32 is running. So that's just kind of a built-in test for that. If we go ahead and hit the spacebar, we can see that we're running the CPM, and we can type X and then yes, and now we can do a DIR. And we can see what's going on with the machine. There's also lights happening here when we do like a DIR. You get transmit receive lights. I will try to get a shot of that as well. But the key thing is, like if we go to G, that's my games directory. You know, we can actually pull up and start running Adventure, which might be fun to do one of these days. I don't know. We don't need instructions. It'll tell us the first room we're in. You know, cool stuff. I mean, this is the classic way that you used to do stuff. I'm gonna quit. So that's it. So what we're doing is we're taking 115.2K baud on the bus, the transmit receive. We're converting it through a number of chips, you know, to get the voltages correct. And then we're outputting it at 9600 baud. Now, because I'm using the ESP to do all that, it's all in software. It's really pretty easy. So yeah, this is something you could be able to do and make. Now, you know, like I've been kind of hinting at, there's a kind of a bigger, maybe future project where we upgrade the CPM version so that it supports the 2 serial ports, and maybe we get the second serial port to be the interface to, I'm going to give air quotes, a modem, which is really the ESP32, and using some software we get on the internet, making it look like a modem. So I think that's actually doable. It just depends on if I'm going to have time to work on it. But, I mean, you certainly get an idea of what's possible here. I've seen online some people asking about, you know, baud rate conversion and stuff like that. This is certainly one way to do it, depending upon the buffer that you set up. So going from a higher speed baud rate to a lower speed baud rate, you're always going to have buffer overflows. If you have a constant stream of data and you're not using like data terminal ready, any kind of form of handshaking, which I'm not in this case, but we could. It could be modified to support that. In this case, I believe I'm using a 2K buffer, and you know, walking around, looking around the drives, playing games, that kind of stuff, you're not really going to fill that buffer up because you've got pauses in between, which allow it to empty out. All right, so that's pretty much been this project. I think it's kind of cool to be able to look at an old terminal and use it to talk to a device like this. There's actually things online. You can actually use an old VT terminal to also talk to Linux machines, which might be kind of fun to do one day. But I've been working on this project for quite some time. I've hinted at sharing it with you, and I really wanted to get around to showing you. So that's it. A baud rate converter for the RC2014. All right, guys. Take care. Remember, learn something new every day. Bye. This shot was a pain in the butt to set up.